In this section of our video solutions to the first 9 weeks test, I want to talk about problems, I guess they're 14, 15, and 16. Two of them are strictly memorization problems. Um, the derivative definition is the limit as h approaches 0. Notice that where the limit is, it's on the right side of the equals here. The limit h approaches 0. F of x plus h minus f of x over h. You just have to memorize this and just write it down 10 times in a row and you'll have it. Okay, we're going to use that definition in finding the derivative of the f of x equals the square root of 2x. Let's make a note that because we're going to have to calculate f of x plus h, if you look at the rule right here, let's just go ahead right now and write down what f of x plus h is. F of x plus h is what you get when you put x plus h in for x. So x plus h has replaced that x. It's going to replace this one. So this is the square root of 2 times the quantity x plus h. Are the parentheses required? Yes, they are, because if you don't, you're going to just get 2x plus a single h, whereas this guy would distribute into 2x plus 2 h's. Okay, and that'll be important. So we're going to start off with our limit. F prime of x equals the limit as h approaches 0 of f of x plus h. Well, that's our 2 times the square root of 2 times the quantity x plus h. Minus f of x. Because that's what the formula says. Well, our f of x was the square root of 2x. So minus the square root of 2x, all divided by h. And all we've done at that point is plug into the formula. Please show that step and show all your work so you can maximize your credit. Or since we actually know now how to take this by the shortcut rules, you could behind the scenes use the shortcut to check it out, but no credit would be given for the shortcut because that's not what this problem is about. Okay, now what we're going to do, whenever you have a square root minus situation, you multiply by that square root plus. Or for the square root plus, you multiply by the square root minus. We're multiplying by what we call the conjugate in this case. So I'm going to multiply by the square root of 2 times the quantity x plus h minus, plus because we did minus before, the square root of 2x. Now you can't just multiply by something without changing the value of the fraction unless you do it top and bottom. Then you're multiplying by 1 in a fancy form. So this will be the square root of 2 times the quantity x plus h plus the square root of 2x. Sorry for getting messy there. That's the square root of 2x. Okay, now the reason you do that is you're trying to set up the fact that whenever you take a plus b and multiply it by a minus b, which is what essentially you're doing here, you're going to get a squared minus b squared. And when we square these square roots, they're going to go away. So this numerator, so this equals the limit as h approaches 0. In the numerator, I get the first term squared minus the second term squared. That's the a squared minus b squared result. Well, when you square a square root, the roots go away. So this is 2 times the quantity x plus h minus 2x divided by. In the denominator, don't try to combine things because it just makes your life harder. This is going to be h times, and then the quantity, the square root of 2 times x plus h. And this would be plus the square root of 2x. And all I've done is indicate that I'm going to be multiplying that times that. Make my h a little better looking there. Okay, now in the numerator, I'm going to write equals the limit h approaches 0. In the numerator, I'm going to get 2x plus 2h when I distribute. well, we'll just show the step. This is 2x plus 2h minus 2x over h times the square root 2 parentheses x plus h plus the square root of 2x. In the numerator, the 2x's cancel, leaving only 2h. So this is equal to the limit as h approaches 0, 2h over h times, parentheses, the square root of 2 times x plus h plus the square root of 2x. Now the h's can cancel. This is the limit as h approaches 0 of 2 over the square root of 2 times the quantity x plus h plus the square root of 2x. Okay, if you're asking yourself, when can I quit writing the h goes to 0? The answer is now. We're going to take the 0 and plug it in for h. We could never have done that before. You can hear my dogs. And my wife. Okay, so if I put a 0 right in here, this just becomes the square root of 2x. So I get 2 over the square root of 2x plus the square root of 2x. Well, that's going to be 2 over 2 times the square root of 2x. Now your 2's cancel. And finally, this equals 1 over the square root of 2x. And that is your derivative. Okay, a lot of detail work there. To finish off that set of questions, a function can fail to be differentiable in 3 ways at x equals c. If it's not continuous at x equals c, the derivative will not exist. If the graph has a sharp turn at x equals c, it will not be differential there. Or if the graph has a vertical tangent at x equals c. If any of those 3 things are true about f, then the function fails to be differentiable there.